Thanks very much. First of all, thanks for coming. Can you guys hear me okay?
Yep.
Yeah?
Yeah.
I can
Go
go.
in India.
Yeah, definitely.
Yeah, I can't compete with that what's going on outside. But look, let me start a little bit and talk about what our perspective is on the industry in general. We're still very bullish at this show, like we have been, quite frankly, for quite a while. I mean, we're looking at a 15-year upcycle in commercial aviation, and 2016 forecasts look even stronger than 15 if you look at IATA's figures. You know, we're talking about demand growth for passenger traffic of 7% after a year of 6.5% and 14 at 6%. You're looking at fuel prices that, compared to 14, are almost 50% reduced, which is the largest variable cost for our airlines. We added 2 million departures year over year, 15 versus a forecast for 16. I'm talking as an industry. Load factors are at 80% across the industry for the second year in a row. So the commercial market continues for us to look like it's a very robust market, and we're very happy with our positioning. Bill will go through a little bit of what is going on in the commercial, but suffice it to say, with LEAP going into service in July of this year with Pegasus on the NEO, and certified on the Boeing application, LEAP 1B ready to go into service next year, the 9X first engine to test ahead of schedule. We're feeling very comfortable with where we are. We have a lot of execution that has to occur in the commercial portfolio in order to fulfill the commitments and the trust that our customers have given to us. We have over 10,500 LEAPs on order. We have over 700 G9Xs on order. We got a lot to do. We've got to make sure that we fulfill those commitments. At the same time, if you look at the military market, you're on the precipice of some new technologies, whether it be the Advanced Engine Program, AETD program, which Gene will talk about, which is a new contract we just got for $1 billion, or whether it's taking all the technologies we've been investing in over the last 10 years and now putting them into our installed base in the military, and bringing our services portfolio as well as our digital portfolio into the military world. We're on a precipice of some great science and technology programs, some new development MPI programs, as well as upgrades in the military. At the same time, in commercial, we're working to finish the transition of that entire portfolio. And to put it in perspective, just think of a world where 320s get replaced with NEOs, 737s get replaced with MAXs, 330s get replaced with NEOs, 340s get replaced with 350s, 76s get replaced with 787s, 777s get replaced with 777Xs. This has been an incredible transformation in the commercial portfolio in a very short amount of time. So think about 30 years of kit that's being replaced in less than a decade, and that's really what we've done. For us, since 2010 through 2016, you're looking at $7.6 billion of research and development spend and another $6 billion in plant and equipment. And now it's time for us to execute that portfolio and make it come to life in front of our customers, and we're very excited about the opportunity. So in general, I would tell you that from GE's point of view, 46,000 engines in the field by 2020, a backlog now of almost $154 billion, 48% growth in that backlog in the last 3 years. We're feeling pretty good about the business and pretty good about the environment that we're working in right now. So with that, I'm just going to start going down the table. I'll start with Bill Commercial, and then we'll just go to Gene, and then Kevin, and then Jim. Okay?
Great. So good morning. From a commercial engines perspective, David talked about it. We're in the middle of this decade of portfolio renewal. It began with the introduction of the GEnx in the 2011 timeframe. We've shipped over 1,000 engines now. The asset has terrific fuel efficiency versus its competitor and a terrific reputation from a dispatch reliability perspective. Then you move to the LEAP product, which we've really been focused on quite intensely over the last 4 years or so. And the exciting thing for us is we've been able to deliver on what we said we would do. We've been on time or early to each of the milestones, from first engine to test to first flight, literally 4 years to the month that we told the industry we would do it on the NEO. Similar story from a MAX perspective. We're very excited about how those products are both flying. Certifications are done from a FAR 33 and FAR 25 perspective on Airbus, and Pegasus will take their first plane next week, which is a terrific opportunity and responsibility for us. And And now we're positioning, associated with finishing out FAR 25 from a LEAP perspective, and making sure that that asset is ready to go early next year. So I think, solid execution, now a focus on making sure that we're ready to deliver from an entry to service perspective. And then, we sort of finish out the decade with the introduction of the GE9X, a product that, we spent the better part of 5 or 6 years developing. We actually pulled in the first engine to test to make sure that we could assure ourselves of a common configuration in that asset through the certification program. We pulled it in about 4.5 months, and we still beat the date that we had set, March 28th, by 3 days. That asset is running in Peebles, Ohio. We're quite excited about how it's performing, and we're positioned well. And we did this all while delivering, record output from the traditional product that we produce, including 1,700 CFM engines this year and another 200 or so G90s and about 250 GNXs. So, we're pleased with how it's performing. As David said, look, now we've got to execute. We've got great responsibility given to us by our customers, and our focus is to make sure we deliver.
Gene?
So we couldn't be more excited about our military engine business right now and the opportunities that are ahead. I'm going to talk about it in terms of our 3 major segments: rotorcraft, and then combat, then our international growth. Starting with rotorcraft, we have reached qualification for our T408 engine. That enables us to go into low-rate initial production for the CH-53K helicopter for the U.S. Marine Corps. And that program has been a model development program on cost and on schedule, and it's doing extremely well as Sikorsky progresses through its flight testing. Secondly, we have our GE3000 engine. This is the next generation of the T700 engine for the Black Hawk and the Apache. And we have successfully completed 2 full engine tests, as well as numerous rig testing, and all of the requirements that the Army has established for that engine have been met. We're very, very pleased with the results. And we also have a FATE program, the Future Affordable Turbine Engine Program. This has been another great success story for us. We completed the compressor rig and demonstrated the highest compressor pressure ratio ever in the history of GE Aviation. So we're getting ready to run our first engine to test later this fall. I'll summarize the rotorcraft segment by saying that between the GE3000, the T408, and the FATE engine, we cover the full spectrum of requirements from 3,000 to 10,000 shaft horsepower. And all of that technology is leverageable and scalable as the Army is assessing its needs for its future vertical lift. Moving on to the combat segment, we are the only engine company that was competitively selected to work on the first 2 adaptive engine cycle programs. Started with the Advent program back in 2007. We ran a core test, and as part of that, we demonstrated the highest combination of compressor and turbine temperatures ever in the history of jet propulsion, and that was validated by the U.S. Air Force Research Lab. We went on to run a full engine test. We are the first and only engine company to say that we have successfully demonstrated multiple conversions in the adaptive cycle engine, going from high bypass to low bypass. And of course, that's critically important now in a military combat mission, allowing the engine to morph from that very high fan pressure ratio for takeoff and acceleration, as well as converting to a low fan pressure ratio for maximum fuel efficiency when that high thrust portion of the mission is not required. In 2012, we were awarded the Adaptive Engine Technology Demonstrator Program. We are in the process of running rig tests right now, and we'll run a core test later this year. And then, as David mentioned last week, on June 30th, the Air Force awarded us a $1 billion contract for the Adaptive Engine Transition Program. We are looking forward to maturing the design through detailed design review, There are several full engine tests that are expected to run between now and 2021. And this contract includes a priced option to run the engine in an F-35, as well as another option to define the propulsion requirements for future combat aircraft. And then I'll finish with the international growth opportunities. Korea has selected our F-414 engine to power their indigenous fighter known as the KFX. We officially signed those contracts with KAI and Hanwha Techwin last week. Saab has also selected our F-414 engine to power the Gripen 39E. All of the engine ground testing qualification is completed, and we are getting ready to support Saab in their flight testing efforts, which will begin later this year. And we are also powering India's light combat aircraft Mark II in addition to the Mark I, and our engine ground testing for qualification is also completed on that front. As we look toward the future, we're going to be working with the Indian government to potentially power their advanced medium combat aircraft with an upgraded 414, which may also have tremendous benefit for the U.S. Navy on the F-18 Super Hornet and Growler. We're also working with the Turkish government on their indigenous fighter known as the TFX.
On the services side, I'll talk about three of our big priorities for the year. Number one is always to maintain the lowest engine-related direct operating costs through the life cycle of the motor. And Bill talks about how technology flows forward into the GNX, into the LEAP, into the G9X. In the services business, we work on bringing technology back into the install base. So if you look at a GE90 115B who entered service in 2004, today the time on wing is 15% better. Fuel burns 1.3% better. If you look at the Dash 7, went into service mid-90s, today 20% better on time on wing and 2% better on fuel burn. So our prime focus has always been technology into the installed base for low operating costs. Two other areas, first of which is True Choice. It's making sure we can customize the best commercial offering for our customers, no matter where they are in the life cycle of the engine, whether they want a 15+ year risk transfer product, whether it's an MRO where we're working on a combination of new, used and repair parts, or whether it's helping customers transition product from one owner into another. Our True Choice portfolio is a simpler, straightforward, very customizable platform for offerings to our airline, MRO, and leasing customers. And last, to really lead in digital and analytics. It's for us, it's an incredible new toolkit. And just think about the landscape that we're in services. 35,000 engines out in the install base, an airplane taking off every 2 seconds powered by G and CFM, in a wide range of operational and environmental conditions. Engines flying in hot, cold, sandy, salty environments, short flights, long flights, and many airplanes, all of the above. Analytics gives us an ability to make quicker, better analytical decisions around reliability, around time between maintenance events, around work scoping an engine. It's been a big enabler. It's, to me, it's personalized medicine by engine, and it's a chance to, and fundamentally personalized medicine down to the part level, and a chance to really move into the realm of predictive analytics around reliability and durability.
Jim?
No problem. All right, thanks, Kevin. Kevin kind of touched on some of the digital elements that are going on here. So I guess welcome to the Aviation Digital Industrial. We've actually been on this journey and kind of accelerated in the last, I'd say, 3 years or so. Some of the things that Kevin touched on, we found as we kind of went down this path, everyone's heard about big data and analytics and everything else that goes along with it. And we found that the real power for us in aviation was really the combination of the analytics, the statistics, along with the physics, as Kevin mentioned in many cases there. I think some of our initial successes that we had from an engine's perspective were related to that marrying of the of the physics and the analytics, as well as being early adopters for the Predix platform. I think everyone's heard what GE Digital is doing. We in Aviation Digital are standing up our own division, focusing on aviation digital solutions as well, and we were early adopters of Predix and have been using that in some of the solutions and some of the successes that Kevin mentioned earlier. Our focus now is to really expand that beyond the engine. Obviously, building on our expertise, domain expertise that we have in aviation. You consider avionics, navigation, flight planning, all those type of things, to a much broader spectrum of what the aviation industry really needs in terms of the solutions for the really hard problems that are out there right now. One of the key ways we're approaching that is getting with our customers and just asking, what are the hard problems that you need us to solve, can help you solve with the platform, with our domain expertise in digital, with all the data that's flying out there, all the big data, to bring those solutions to you to really optimize your particular operations. Doing that through our collaboration centers. We've actually got a few of those already established throughout the world. We started with Dubai late last year, Paris we opened a few weeks ago, and next week we're opening in Shanghai. And then later this summer we'll be opening in Austin, Texas, and we're still looking for a location probably in the Southeast Asia region. I think you guys are fortunate today. We've had an opportunity to set up a sort of a scaled version of our collaboration center here downstairs. We'll take you to have a look at that. But to give you an example of some of the things that we're looking at, some of the things you can see along with the True Choice offerings and how digital has really enhanced those, as Kevin mentioned earlier. But we've got some network optimization insights from a solution perspective that are actually gone live, are in real time on Predix right now. And actually 2 weeks ago was put into the operations of Fly Dubai, so they're using it. So you can see it happening in real time right now, but that shows kind of power of what digital has done. Predix is real, it's alive, and how we're identifying some solutions in our collaboration centers with our customers. Very much like what you'll see downstairs.
Right.
Okay?
Well, that's a lot to take in 15 minutes, but we know your time's busy now. We'll open up some questions. John?
David, unsurprising question about the middle of the market airplane.
Yeah.
What types of technologies are you ultimately hoping to take from where you are today to look at a 40,000 pound engine that Boeing is sort of visioning for this? How do you kind of see the buying patterns for a middle of the market airplane, small twin, big single, and how it kind of fits in with your overall strategy?
Actually, John, we're very bullish on the technologies that we developed. You know, just again, go back to where we are right now. You know, with all the development and all the technologies we put in the motor so far. The first place we're going to take today's technologies is in upgrades and advancements in Gene's world, and then we have another suite of technologies just waiting for middle of the market. One of the things we're very excited about, first of all, we think with the given architecture that we've got, two-spool, we believe a two-spool architecture can get us the efficiencies that the middle of the market airplane is talking about. We have a lot of technology waiting to go into that airplane that we haven't introduced yet. 9X is the perfect example. In 2020, we'll have the 9X engine. Look at the suite of ceramic matrix composites that we're putting in there, as well as additive, along with, quite frankly, the advanced turboprop engine that we've just announced. The amount of additive work in that advanced turboprop will be the most we've ever done in a jet engine in our history. And what we're learning from that is that the designers are thinking quite differently about the way they design, both in terms of weight, cost, and performance. We have a program right now where we took one of our existing engines in service, gave it to a little skunkworks team, and put them on the side and said, look, use additive and make this engine better. They came back with literally very little change in actual flow path design, with almost a 7-point improvement in fuel burn. Just using additive, they took out 800 parts using additive, and they reduced the weight of the engine by almost 12% using additive. So, you know, additive is more than just the new manufacturing technologies. It's a new advancement in the way we think about design. It takes constraints that we have today and throws them away and gives us an entire new canvas to paint on when we think about it. So I'm not going to tell you about the specific technologies, but suffice it to say that we really like our technology portfolio. You know, you hear us talk about the GE Store, which is true. We invest in technologies as a company. We use them across the different businesses a lot. So I like to shop in the GE Store from power and from oil and gas and from transportation and from healthcare. And they like to shop in the GE Store and pick up the things that I'm investing in so that we get a bigger bang for our buck on all our investments in technology across the entire corporation.
But at the end of the day, you feel like the size of the market that Boeing sees is ultimately large enough that you
No,
guys
no,
don't-
I would tell you, just like every one of these decisions, I think Dennis said it right. I was reading his comments this morning. You know, you always have to evaluate the business case on all these. You know that. I mean, it's literally, these are not trivial decisions. You're going to enter into $1 billion+ program if you're in the engine business doing a new motor. We would do it with CFM. It would be a CFM engine. But together we have to make sure we're comfortable with the business case and make sure there's a family of airplanes out there that has a big enough volume that we would do the case. If that's it, we feel confident we can bring the technologies in the engine to meet what the requirements for the middle market airplane is. We still need to make sure the business case goes.
I'll follow up. What is your analysis of the business case? How many of these planes do you think could be sold over a 20-year period?
You know, look, the numbers vary. They vary a lot. They vary. From
I've seen as low as 2,000.
Well, they vary from 1,500 to 4,000, depending on who you believe, right? And so, I think at this point in time, you know, I think there's a lot of interest in the middle of the market airplane, but I still think the key is understanding what the entire competitive dynamic in that space is going to be. When you launch one airplane, it's not the only airplane that's going to get launched into the space, right? And so there's a number of airplane solutions that exist in that space at the end of the day, and we have to make sure that we're comfortable with the business case closes if we get in there and compete.
But you must have your own opinion.
I do.
You guys say.
Gene, just to follow up, there was a couple points you made. One, the priced option on the competitive, priced option on the F-35. How do you do that in that small space with a wider, necessarily wider engine? And with the priced option, is both Pratt & Whitney and GE going to get that, or do they select one or the other? Sorry, and then on the Super Hornet side, you mentioned the engine upgrade with the Indian program. Is that funded? And then how would the Navy join that? And is there any plan in the POM or anything like that looking forward to that direction?
Okay, so the question on the priced option on the AETP program, yes, both GE and Pratt & Whitney received the same priced option. I will point out, though, you mentioned it's a wider engine. The engine that we are going through the next phase to get to detailed design review is specifically sized for the F-35, so it could be a plug and play. If the Air Force and the DoD decide to put this engine into the F-35 in a block upgrade fashion, as they've done on combat aircraft in the past. Relative to your question on the F-414 upgrade for India, we are looking at studies with the U.S. Navy, and there are government-to-government discussions going on between the U.S. and India in regard to this upgraded 414 and how that engine would meet the needs of the advanced medium combat aircraft.
And then how does the U.S. Navy jump into that? You mentioned it would be available.
So the engine would have a lot of similarities for the two applications, and we would be able to reduce the overall development costs for both applications by working in a synergistic fashion between the U.S. government and the Indian government to satisfy both needs.
I know.
Yeah, Bill, can I just verify on the G9X testing?
Yes.
You said you're very excited about the sort of performance you're seeing. First of all, can I ask a bit more detail perhaps on where you're going
Sure.
with that?
Sure.
Secondly, just looking more strategically, do you see there's potential follow-ons from the technology that you're getting out of the 9X that you could feed back into the GNX as you continue to upgrade that program?
Yeah, so from a 9X perspective, running very well. We've demonstrated, above the 27-to-1 pressure ratio that we talked about. It has. I'm not going to comment on the fuel efficiency aspect of it, other than to say, look, it's meeting the expectations that we set forth. That both we and Boeing are pleased with that. We've run the full car that we had expected to run, and now we're teasing out, the final features associated with it from a first engine test perspective, and then the terrific design engineering community that put this thing together is taking that feedback and tweaking it as we position for second engine to test in the early part of next year. So we're quite pleased with that. Associated with the technology, and I'm glad you asked about it, the technology for the next generation GNX is hiding in plain sight, because we're actually running all of the CMC capabilities from a 9X in the GNX now, and we're on our second test of this, right? So we're sitting at 3,200 cycles of demonstrated capability with a GNX engine that has a CMC combustor in it, CMC stage 1 and 2 nozzles, CMC shrouds. So all of those things have application for the GNX at the right time, and Gene's run a high pressure turbine blade in that regard. So it's all about how do you use the technology investment over and over and over again, and to our collective advantage. And I think commercial side has benefited quite a bit by the investment on the military side, and I think that's now taking place as she goes into her decade of portfolio renewal.
So when could you see the packaging, say, as an upgrade for the GNX?
No, we're in the process of evaluating that now, and really depends on the data that we get out of those tests and what makes the most sense then.
Anybody else? Yes.
David, you've got a massive ramp up in front of you. How do you manage your supply chain in that regard, and also how do you integrate your supply chain with the developments from big data and service and support that are coming down the road?
So the ramp rate obviously is on everyone's mind, including ours. For us, this is not foreign territory. We're going to build 1,700 CFM engines this year, just on the CFM family alone. Our total, what's our total this year?
1,700 on the CFM.
No, what's the total commercial and military?
Commercial and a little bit over 2,800.
Just on commercial, but military is 30.
This gets to 33, I think.
3,300 this year, total engines across military and commercial. So you can imagine we've been doing everything we can to make sure we can run at rate. We've been running at rate early and then verifying, running all kinds of tests. So we'll push the rate 6 months ahead of when we need to be there, find out where the weak link is, and continue that kind of approach the entire time. We feel very confident with the alignment and the connectivity of our supply chain. In fact, recently Airbus just finished an audit of us and gave us the highest grade that they have in their portfolio, thanks to the rate readiness for the NEO. So this is not uncharted territory for us, and we certainly respect and appreciate how hard it is to do it. And we've got a lot of folks just absolutely focused on the execution of the rate. Oh, let me answer the big data question, because this is really important. Jim is teaching us how fast we can learn inside our own shops, as well as what we can do with customer data. So we call it a digital thread, quote unquote, which is really, the thread of data that exists throughout every one of our production facilities, and how taking big data off of our production facilities and putting it back into our decision making allows us to have incredible speed in learning and productivity, and it's very much helping not only our rate readiness, but it's teaching us to think about productivity totally different. And I'll give you an example. And in fact, I gave some of you this example before. We're looking really hard at the imaging technologies that are being developed in our healthcare business for recognition software that we can use for inspections in the aviation business. And it's an amazing, both in Kevin's engines that come out of service, as well as in Newmaker. And so, and it's all big data. It's just big data plus having the domain expertise associated with engines. Applying those together give us incredible productivity and efficiencies that we can look for to help us with these rate readiness challenges. And so I can tell you digital is a big piece of this. It really is now and going forward.
Sort of back on that middle of the market thing, last year in Paris, I think your message to us was sort of, let's just focus on what we've got on our plate already, with the ramp up development programs. And there's still the A350-2000 talk out there in the middle of the market talk, but has your position changed any with this year?
No, I think it's exactly the same, and that is, we will always be competitive when an airplane is ready to go and the business case closes. Don't underestimate our competitive responsibilities as a company. That being said, if you simply take a look at all the execution, all the customer requirements, the commitments we've made, we have 10,500 leaves to deliver. We have 700 GE9Xs delivered. We're on our 1,000th GEnx now in service. fulfillment, execution, making sure our customers are confident that we can deliver what we've committed to them, it's got to be job one for us, because our reputation and brand is dependent on how well these engines go into service and how well they satisfy the needs of our customers. That will lead to a middle-of-the-market airplane with a differentiated engine and brand for GE and CFM. But right now, we have to execute in a way that we can make sure that our customers are as confident and comfortable with what we deliver to them as we are. And I'm thrilled. We, on time, on performance, reliability looks great. I'm thrilled with the 9X first engine to test. On time, performance is right where we thought it would be. The guys are actually running the first engine longer than we thought they would, so that they can actually take it a little further than we thought we would, just so that we can get a little more learnings early than we thought we would. So, and to your point, the technologies associated with both of those engines end up manifesting themselves in the next generation of engine and the next generation of upgrades, both in terms of the commercial and the military portfolios.
You're gonna have to get you winded down.
Okay.
Hey guys, Dave's got to go do a quick live TV deal, and so but the team is all here, so feel free to ask questions. They've got time, and then if you have your time after this is done, I'll let Jamie monitor the Q&As. He's my boss, so he's going to step in and do that. And these guys can take out a little tour if you have time at the Collaboration Center. If you don't have time today
Come back.
because of roles, please come back. We'll do that. All right. So feel free to ask more questions. Great.
Jake, just in terms of the timing on ATP for the drop-in option, is there a specific time when that might be, like 2019 or 2020?
Timing on AETP is the current contract will run through 2021.
Right.
And so then it will be up to the DoD and the Air Force to make decisions about next steps and what the schedule will look like for a potential follow-on EMD program.
Okay, so that would be the drop-in time for, the priced option, that is, for the...
That's right. That's
So
right. So when we
post-21.
get to the detailed design review, that's when the Air Force is expected to make a decision about the options and which path that they will pursue, which one or ones they will pursue. So we'll continue on our path, run these, full engine tests, and the technology has really proven to be something that the Air Force is very, very interested in as they look toward future combat aircraft.
The GE3000
Yes.
at phase. With the Army's looking at FDL, do you have any sense yet, with FDL medium in particular, whether you're looking at like a scale up of the GE3000 or some usage of the Fate?
We are trying to cover all of the bases on that, Steve. So the GE3000 has inherent growth capability. We can go beyond the 3,000 shaft horsepower capability that the engine is currently demonstrating today. The Fate engine being on the opposite end of the spectrum at 10,000. The technologies are being developed. As I said, they are leverageable and they are scalable. If the Army needs something that needs to be smaller than that. Of course, we do have the T408 sitting right in the middle at 7,500 shaft horsepower. So that's why I made the comment that we've covered the full spectrum, and we think we're going to be able to scale that technology regardless of where the Army lands on the medium capability set.
You don't have a sense yet of where that Army vector is?
It's moving around quite a bit right now, and I think that's probably the most appropriate way to answer the question. So we're watching it closely, but trying to be positioned for all possible outcomes.
Well, listen, we'd like to leave a little time